Hello and welcome to our GDC 2007 AI implant demo. This demonstration is all about AI for massive destruction. Last year, we came to GDC with a demonstration of destructibility and how you could move objects around in a physical environment. And really what we wanted to show off was it's an awful lot of fun to be able to blow up an environment and have the AI react to that. So here you'll see there's a demonstration of a bunch of ducks in the background that do exactly that. They react to a dynamic environment. And you'll notice while I'm playing the game that I'm able to destroy the environment. The ducks are moving around in the background. Their goal is to get to the gun, and what they'll do is they'll do anything and everything to do that by moving around everything that's moving in the environment. Now really this was our first attempt to deal with these types of physical environments. It's not that sophisticated, but we did realize that this was important and we wanted to be able to continue having dynamic pathfinding. So here we are at GDC. We're releasing version 5.0 of AI.implant. That's about 7 years in the making. We have a deep Unreal 3 integration, meaning that we were the first AI middleware in the Integrated Partners program. We have some proven technology for you. We've been working with Midway, we've been working with Electronic Arts, Vivendi, Sony, BioWare, all of which who've helped us to win a few awards. And recently we just won the Game Developer Magazine's Frontline Award, Best Middleware. Now, the demo that we want to show you is all about massive destructibility. We want to be able to blow up an environment, show you some cool stuff, but really it's about how you can have next-gen gameplay or not scripted gameplay in your titles. We really want to be able to have an open-ended sandbox type of feeling when you're playing your games so that you can let your level designers have a little bit more creativity for your content creation. Now, without further ado, let's get into the games. Let me load that up here. So here we have our demo. I'll just grab a couple of weapons and get through this over here on the left. Alright, so now I have a few weapons, and what we want to talk about is the difference between static versus dynamic. So you see the first character is using static pathfinding to get to me. Now, of course, when a static character encounters something dynamic in the environment, they'll actually have difficulty because there's no pre-markup for that object. So here I'll spawn a second character, and you can see that they get stuck behind that object. Now, our system is a different type of system where it's an area-based solution where we mark up the objects in the area as opposed to using something like path nodes, which were the gray lines that you were just seeing. Now, when a character moves through the environment in our system, they know how to get around the obstacles directly, as you can see there. And if I change the environment or move things around, you can see that the character now modifies their path in order to get to me. Now here on the left, what we have is we have an area that is blocked off. So the character, as soon as they're spawned, they'll realize that they can't get down the railing, so they'll come around the long way. Now, if I were to go in and create a slightly bigger hole, this time round the character will be smart enough to know that they can actually get down by jumping toward me. So get rid of that guy. And so over here what we have is we have a character is able to walk straight through the corridor, whereas if I were to modify slightly the environment, this time the character knows how to vault over top of objects. Now again, if I go up to that object a little bit to the side, you'll see that they know how to navigate around. The last piece here, you'll see that when I spawn a character, they come straight toward me. Well, that's interesting. In most path node systems, that will happen, but it will be very robotic. They'll stop and they'll turn, whereas in our system, they'll move straight towards you. If I modify the environment slightly by knocking down a box, you can see that the character was able to get around. And if I block everything off, then when I spawn the next character, you'll see that they'll be smart enough that they'll actually be able to get around, taking the long route, jumping down and getting to me that way. Now finally, so far you've seen a bunch of rigid body objects, but what we're going to be dealing with is dynamic objects. So I'm going to go in here and I'm going to mess up the environment by blowing up some destructible objects. And now if you look, you'll see that the character is able to react well and get around all of those dynamic objects. Another interesting aspect of our software is that we can create a cache. So whether I'm playing this on an Xbox 360, what I can do is I can generate an ACX file that I can look at afterwards inside of our debugging environment to identify issues and hand those off to developers. So as you can see here, I'm looking at a bunch of green lines, and there's visualization that can be used for debugging, and I can step through and say, aha, you see that point up there? Well, that point really is something that shouldn't be there, and then get that fixed.